Okay, so we're going to talk some more about polymorphism with this one. Just a really brief recap last time. We had something like this. So we have an A, that's its static type. The dynamic type is B. And when we see if foo can be called on the A, it looks at the static type and says, do you have a foo method? Yes, it does. Awesome. Then when we call foo, it looks at the dynamic type, B, and says, do you have a foo method? If it does, it calls that one. If not, it keeps going up the chain until it finds the right one. In order to know how that works, we need two things. This little table. So the variable A is of type A, the static, versus the dynamic. The dynamic type is B. And we need the hierarchy, A, B. Foo method is up here. So let's say that's what the hierarchy looks like. This is an abstract or a concrete class, and it's got an actual body for the method. So looking at just this, A.foo, A is an A. This is what the compiler is going to look at, and it's going to say, does A have a foo method? Yes, it does. When at runtime, it's going to say A is a B. Does B have a foo method? No, it doesn't. So it goes to the one in A. Again, it doesn't literally do that. It would be far too slow, but if we pretend it does it, we'll get it right all the time. If however, B overrides foo, then when we say A.foo, we're looking at runtime, we're looking at the dynamic type, B. There's a foo method there, we call that one. So this little chart, so this is, I guess, the variable name, the static type, the dynamic type. So this little chart is really handy. If we draw this chart, it's really hard to go wrong. When you get good at it, you can keep the chart in your head. And then here, same thing, you just need to draw that hierarchy. So that was the first part where people tend to make mistakes. They go, well, lowercase a is declared to be an A variable, so I always look in the A class for the foo method. I don't. It depends on what I said in new one. Now comes the other part. So let's say we have an abstract class. A. There's more code here. Okay. So where do we look for that? Now, let's assume we have that same thing, that same table. A is var static type, the dynamic type. This is an A, and this is a B. Now, when we call a method, so that would be A.foo, we get a new variable. We get this. And this is actually just pointing at A. Right? So we could just say that this points at A, or we could repeat the information here. Your choice. So this here is the same as saying this dot bar. Now, because we're calling a method on this, we do the exact same thing. The compiler is going to say, we're in the A class, so it knows that. So we're in the A class. That's what this static type is. It has to be. So the static type is A. Does it have a bar method? And either it'll have a bar method, or there will be a bar method up higher in the hierarchy. It has to be at least here or higher. So let's say it's here. So where students make the mistake is they say, okay, well, we're calling bar, this dot bar, or just bar, they're both the same, and there's a bar in here, so I'm going to call that one. But that's not right. Same rule applies. This is dynamic type is B. So we have to go to the B class and look, does it have a bar method? If it does, that's one we would call. If it doesn't, then we call this one. Or we go up the hierarchy until we found one, right? So The rule is exactly the same. There's no difference between calling a.foo or this.bar. They're the exact same rule. In fact, this is the same as a in that case. So when we say a.foo in the previous screen, the previous whiteboard, right? What we're saying is look at the dynamic type, B, and call the method on that class. And it'll look in that class or keep going up. When we call a.foo, right, this magically appears. This and a are the exact same thing. So we have the exact same information. So when we call bar, no different than when we called foo. What we did when we called foo was we looked in the dynamic type and looked for it. When we call this bar, we look in the dynamic type and look for it. There's no difference in the rule. It's one rule, actually. So students get confused in two different ways for the exact same thing, right? So hopefully this little table will help erase that confusion. There's one other piece to go along with this. So let's say we have our B class that extends from A, just like before. And let's say it overrode bar. And let's say it calls super.bar. So super means call the parent class. So let's say our hierarchy is like this. This has bar, and this has bar. So super.bar here, super.bar, we'll call this method up here. If our hierarchy wasn't that, say our hierarchy was this. So now when we say super.bar, it actually has to look in D to see if there's a bar. It has to look in C and see if there's a bar. And it has to look in A. So it'll look in D, and if there is a bar, super.bar from B, we'll call the one in D. If that one didn't exist, it would look in C. And if that one exists, we'll call that one. If they both exist, super.bar down here, we'll call this one. If this one calls super.bar, we'll call this one, but it doesn't have to, right? So super.bar lets you go to the next occurrence of it up the hierarchy. So it's it. It's like this. So A has it, C has it, D doesn't have it, B does have it. So we do our thing, we call bar, it comes down here. First thing it does is call super.bar. Could be anywhere in the method. And it looks in D, doesn't see it, looks in C, and it does see it. Great, calls that one. This one may choose to call super.bar, in which case it'll call A, or it doesn't. There is two things that students will ask. One, can a parent's bar method call a child's bar method? Absolutely it can. It just has to call bar, right? If you call bar in here, it'll do the exact same thing. It's the same as saying this.bar, which means it's going to go back down to the bottom and search again. So that's how you call the child's bar. The other question students ask is, and it's not just students actually, people ask, can I go from this bar to this bar without hitting this bar? No, it's impossible. You only have access to the immediate next method above you. You can't skip it to get to the grandparent method sort of thing. So you can only go to the parent bar method. We can talk more about that later on when we get into design. So I think this covers all the stuff to do with polymorphism. If this makes sense, awesome. We'll be able to move on. If not, we'll spend another week on the material.